Let's examine our analysis so far. So when we left off, we had updated our model to add an offset so that our guess is always 8,585.5 seconds. However, we've just done an information gain analysis to discover that intertweet time is very strongly affected by tweet length and mention distance. Let's update our diagram in order to reflect that. Let's update our regression estimator to include the new features. In our new estimator, we're going to pay attention to, in addition to elapsed time, the length of the previous tweet and the number of seconds that has elapsed since Marco Arment or John Siracusa has mentioned this person. We're ready now to think about a model to implement this new regression estimator. What kind of model should we use? Well, let's think about it. We're trying to build a model that captures the relationship between intertweet time, elapsed time since previous tweet, otherwise known as delta t, the length of the previous tweet, and the amount of time that has passed since a close friend has mentioned him. Let's first consider the classical statistics way of looking at the relationship between two random variables. That would be covariance. Specifically, let's go into IPython Notebook now and examine the covariance between intertweet time and mention distance. So to evaluate covariance between intertweet time and the mention distance, we're going to use the linear regression model from the sklearn package. We're going to ask the question, essentially, what does linear regression think the relationship is between intertweet time and mention distance? So we fit the model. The coefficient of the model will give us our value for covariance. As you can see, the coefficient is quite low, 0.015. This is very strange, right? Information gain and the two histogram plots that we looked at showed very clearly that mention distance has quite a high impact on intertweet time. What's going on here?